So in this video, we're going to do the surface area of a cylinder. So we've got a lot of stuff written up here. I'm going to explain what's going on. So we're doing a cylinder. A cylinder is this 3D shape, which I've tried to write on a 2D surface. It's a can at the end of the day. A cylinder is a can. It looks like a can of soup, maybe. Okay, so a can of soup has a top, a lid, and a bottom, the base. So if you want to draw the net of that, the top lid is a circle, the bottom is also a circle, and these two circles are the same. So if you know the area of one circle, just multiply it by 2, because these are the same. See how these are the exact same areas on top and bottom? Just add them together. So the surface area, SA, the surface area of a cylinder, is pi r squared, which is the area of one circle. By the way, if you want to think of it as r times 1/2 c, which references an earlier video of how to come up with the area of a circle. The area of a circle could be thought of as pi r squared, or also radius times 1/2 the circumference. Either way you want to think about it is awesome. I'll put pi r squared just in here just as a shorthand. So if I have 1 pi r squared for this circle, and I have another pi r squared for this circle, and I want to add them together as part of the net of a cylinder, I would have not 1 pi r squared, but I would have 2 pi r squares. So that's why I have 2 areas of a circle, which is why this part of the formula for a cylinder is 2 pi r squared. It comes from adding up these two, the top and the bottom circle. Now the question is, what is this going on in here in the net? Why do we have this rectangle in the middle of these two circles? We have taken account this top circle here and this bottom circle, the base over here. Now we need to take into account all of the area that is going wrapped around the cylinder. Okay, so the area that's wrapped around the cylinder turns out is going to be a rectangle. So let me show you how. So we have this can and we've got a soup label that goes all the way around it. So if I were to peel off the soup label, the question is, what would the shape be of this soup label when I unraveled it? So I'm not going to unravel this because there's a lot of glue and stuff on it. So what I'm going to do is I'm going to take a similar size label and actually wrap it around the soup can. Okay, so now it wraps around perfectly right here. Okay, so the area of this piece of paper that I put around is equal to the area that is wrapped around the cylinder or this can. So why don't I unwrap it and see what shape it looks like? So I'm going to peel it off, and voila, it looks like a rectangle. Okay, so it's actually a rectangle that is wrapped around the cylinder. So a lot of people think that if you unwrap the label, it'll look like a circle or something. No, it actually looks like a perfect rectangle. So I wrote this rectangle represented here. Okay, now the question is, what is the area of this rectangle? Well, the area of any rectangle is this dimension, whatever you want to call it. You could call it the length or the width, whatever you want to call it, times this dimension. Okay, so if you multiply these two dimensions together, you will get all of the area inside. So all we're trying to do is find the length of this dimension and the length of this dimension. So what are the lengths of those dimensions? Well, let's look at this. Let's go back to our can of soup right here. And let's do this part right here. This, okay? So try to think of this as like the top. So here's the top, and then what we're going to do is we are going to wrap this. You see this right here, and you see this right here. Okay, so what we're going to do is we are going to wrap this around, just like that. So this length from here to here is this length, and I wrapped this length. I'm going to take this length and I'm going to literally wrap it around the circle. Do you see that the length, and the length are all the same? The length of this distance is wrapped around the circle. Okay? Because you need to wrap the label around the can. And so the length is the same, this length of the rectangle is the same as the circumference of the circle. Either the base, either the lid or the base. I mean, they're both the same circles. So if you go wrap around the circumference, that is the length of this part of the rectangle. You see? It just went right around it. So what is the formula for the circumference or the perimeter of a circle? Well, that goes back to pi. So how many diameters does it take to go around the circumference of a circle one time? That kind of sounds like one of those light bulb jokes. How many diameters does it take to change a light bulb? How many I guess 3.14 maybe. It takes 3.14 diameters, about-ish, right? It's pi. So it takes pi diameters to wrap one whole time around the circumference. So that's why the circumference formula, we'll call this circumference formula, I'll call it C. The circumference formula is pi times the diameter. If you know the diameter of a circle, and you know that all diameters of any circle, it takes 3.14 or pi of them to go around the circumference of that particular circle. Pi of them, if you multiply the diameter times pi, you will get the circumference of that circle. And guess what? The circumference of this circle is the same thing as the length from here to here of this rectangle. So if you know what the circumference is, you unravel that circumference, just like we unraveled this label, you will get this length. So it's really kind of odd but cool that the length or this dimension of a rectangle, which you don't think has anything to do with circles, actually in this specific case, when it comes to a cylinder or a can, actually has a length of pi times d. That's kind of cool. Okay, so we've gotten this distance right here. We'll call it pi d. Because that's the circumference. Now, what is this dimension here? Okay, well, let's go back to the trusty soup can. And again, here is the circumference right here. I'm gonna wrap it around. So we've got that. So I'll unwrap it. So this length is the circumference. But what is this length right here? How would we find that length out? Well, it turns out that length is a uniform length. It means it goes all the way around. And do you see that? Here, let's get a shot here. See that? It's the height. The height of the can is the height of the rectangle. The height of the can is the height of the rectangle. You see that? So if you know h, the height of the cylinder, or the height of the can, then this distance, which is right here, is going to be right here. So the height of the can will be the distance for this. So h, or height of cylinder. Okay, you just call it h. H for short. Okay? So what we have done is we have found out the two dimensions of the of this rectangle. The two dimensions are the height of the can, which will be the height of or it doesn't matter whether you call it height or width or length. We're just talking about two dimensions. We found this dimension of our rectangle and we found this dimension of our rectangle. And all we need is this dimension and multiply them together to find the entire area of this rectangle. Okay, so if you want to find out the area of this rectangle, what would that be? It would be pi d. It would be pi d times h, meaning this h specifically, okay? All right, so that's the area of the rectangle. So we have 2 pi r squared, meaning the sum of these two circles added together, 2 pi r squared. So this is the sum of the circles. the sum of the circles, that's how we get this part, plus the rectangular side area, this lateral area. Remember, side means lateral, so I'll use the word lateral interchangeably with side. So the lateral area, or the soup label, you want to call it, is this area, the rectangular, and now we can take this away and actually put in what the formula for the area of this particular rectangle is, which is pi d times h. So it's pi d times h. So this is the full, through the net, through coming up organically through the net, we have created from scratch, basically, the surface area formula for a cylinder, 2 pi r squared plus pi d h. Again, this is the circle part, and then the pi d h part is the area of this rectangle. Okay, so so if you come up with actual numbers for what the h is and what the r is, then you're good to go.